So welcome back, ladies and gentlemen. This is part 4 of our lesson. Just to summarize everything that we're looking at with our task rules in trigonometry, and actually explain why it's called the unit circle. I've actually drawn 4 diagrams on the chalkboard, and again, feel free to pause the video or zoom in or pinch in. And I think everyone can actually see what I've done. So first of all, just to make sure, there's a small disclaimer, we're doing all these questions related to standing position and going counterclockwise. It's just a little easier. And I think everyone actually can see that this angle is 90 degrees. Everyone agree that? That's 90 degrees. Everyone agree? So some of you are probably wondering, Mr. Chen, you told us when drawing your right angle triangle, always make it with the x-axis. And with this angle, we can't do it, right? So there's obviously some problems, especially with 90 degrees, 180, 270, and of course back to 360. So something seems to be fishy about these angles, right? And so we cannot draw right angle triangles. Everybody agree? That's why technically trigonometry is not with this triangle. The reason why it's called a unit circle is technically you can almost envision that circle. And that's literally the circle, right? So a lot of you can see that. So if we make r equal 1, what's r? Well, r is the hypotenuse. Technically, this is the radius of 1. Everyone see that? So let's see if someone's actually paying attention. Let's do the first one in the top left here. Can someone actually predict if that r is 1, what is that coordinate? Really easy. Athena? 0, 1 is correct. Everyone see that? 0, 1. So let's just take a definition of sine of 90 degrees, cosine of 90 degrees, or even tangent of 90 degrees. And again, we'll just do a sketch of what you're used to seeing. That's x, that's not x, that's x, that's y, that's r, and that's our angle, right? Sine, by definition, is the opposite over hypotenuse. Opposite, well, that's y, or the hypotenuse. So what's 1 over 1? Now, I know you can't draw it, you can't see it, right? So the radius is 1. Right? And that actually is 1. Cosine of 90 degrees, well, cosine is the x value, the adjacent side, in this case it's 0, over the hypotenuse. Well, r is 1, so 0, 1, that's 0. Now let's pause here for a second. I want to see anything interesting about this 1 and this 0, and Athena's answer. Anyone see anything interesting? Let's do it again. Notice this answer for sine of 90, that answer is 1. Feel free to check with your calculators. Cosine of 90, feel free, it's 0. Notice there's something interesting about what Athena said. Anyone see anything? Athena again. It's the coordinates. Can someone be more explicit about this? What is this 0 and what is this 1? Let's see if you can now tell me. You guys can't do it? That's okay. In coordinate geometry with a unit circle, it's that. Let's just do tangent. Tangent, by definition, is the opposite over adjacent. What's the opposite? In this case, the opposite is 1. What's the adjacent? That's 0. What's 1 over 0? It's undefined. You can't solve that. And that's why some of you realize that chart that I gave you, that tutor chart, tangent, this is a vertical line. That's why a lot of you actually have been dealing with tangents since grade 9, because it's known as slope. Slope. Let's see if someone actually can tell me this point. Let's just say this radius is again for the 180. That's 1. Can someone please tell us this point? What's that coordinate? Vanessa? Negative 1 and 0. And again, notice it's still the same. Cosine theta and sine theta. And so really what you're doing is sine of 180 cosine of 180, tangent of 180. Now I'm not going to do it this way. I don't like doing it this way. A lot of you are actually slowly understanding that these answers for sine of 180, it's 0. And this cosine of 180 is -1, which is weird. Right? But it kind of makes sense. It's in this kind of region, right? Cast only really works for the region, the quadrant, right? It doesn't really tell us where it lies on the x-axis or y-axis. So I think you guys can finish this off yourself by discovery and figure out what I'm trying to do, and that's why it's called the unit circle. So some of you realize, Mr. Chen, seriously? If I do cosine of, let's say, 60 degrees and sine of 60 degrees, I think some of you actually know what I'm trying to do. If we do these answers, no, this is a Hall of Famer question, so if you do this way, that's 30, that's 60, that's 1, that's 2, that's 3. Obviously I'm dealing with quadrant 1, because these are 60 degrees. Sine of 60, well, that is √3/2. Cosine of 60, that's, what is that? 1/2? So to visualize where that is, that was 60 degrees there. And I wanted to find a point on the unit circle. I didn't draw that very well there, Joe. But that point would be 1/2, comma, √3/2. That's what that would mean. And is there a way to check your answer? Absolutely. Although, if we were to punch them in, we'd get a radius of 2, not a radius of 1. So there's ways that I could use it. Now, this is not the most important thing, but I wanted to kind of tell you why it's called cast, why it's called unit circle, because we're talking about the radius of 1. It actually leads to our future concept that I wish we had more time to do, and it's called radians. Radians, which I am actually supposed to teach you. At North Toronto, we tend to go on, but because of the quadrimester 3, we're not going to do it. But if you really are interested about radians, really quickly, radians, it's another kind of relationship of degrees. We're not going to talk about it, okay? But some of you are slowly kind of understanding there's more to this trigonometry than degrees, okay? Any questions about the class?